Hi Year 12, here are the solutions to the 2021 Extension 1 Maths HSC exam. In this video we'll look at the multiple choice solutions. Question 1. Given that the vector OP is -3, 1 and the vector OQ is 2, 5, what is the vector PQ? So we want PQ is going to be OQ take away OP, which is 2, 5 take away -3, 1. 2 take away -3 is 5. 5 take away 1 is 4. And our answer is C. Question 2. Which of the following integrals is equivalent to the integral of sine squared 3x dx? And we're going to use this formula off the reference sheet. So n is equal to 3, so it's equivalent to a half 1 minus cos 2 times 3x dx, which is 6. So what have we got there? 1 minus cos 6x on 2. Which one is that? That is B. Question 3. What is the remainder when p of x equals -x cubed minus 2x squared minus 3x plus 8 is divided by x plus 2? So we want to find p of -2. It's equal to -2 all cubed, take away 2, -2 squared, take away 3, -2 plus 8 is equal to negative times -8, which is positive 8, take away 2 times 4 is take away 8, plus 6 plus 8. 8 take 8, it's equal to 14, which is D. Question 4. Consider the differential equation dy dx equals x over y. Which of the following equations best represents this relationship between x and y? So let's figure this out. And take the y up on the left-hand side, equals x dx. Going to be the integral, so y squared on 2 is equal to x squared on 2 plus c. And if I multiply everything by 2, I get y squared is equal to x squared plus 2c. This we could just replace with c, so the answer is A. Question 5. For the two vectors OA and OB, it is known the dot product is less than 0. So which of the following statements must be true? So we know that if it's less than 0, we know cos theta is equal to OA dot OB all over the modulus of OA and modulus of OB, and that denominator there is going to be positive. So if we know that this part here is less than 0, then the angle between those two vectors is going to be obtuse, which I think is this one. So our answer is B. Question 6. The random variable x represents the number of successes in 10 independent Bernoulli trials. The probability of success is 0.9 in each trial. Let R equal the probability of x being greater than or equal to 1. Which of the following describes the value of R? Now this is a really easy question. It is just binomial probability, so don't get distracted by all of this language. The probability that x is greater than or equal to 1 means the probability that we have 1 success, or we have 2 successes, or 3 or 4, all the way up to 10 successes, which of course is best done via the complementary event. 1 minus the probability of the thing we don't want, which is 0 successes. Okay, into the formula. This is 10c0 times by the probability of success to the power of 0 and the probability of failure, which is 1 minus p, to the power of 10. Okay, that's 1 and that's 1. So this is 1 minus p is 0.1 to the power of 10. And putting that into the calculator, 1 take away 0.1 to the power of 10 gives me 0.999 ... which is A. Question 7. Which curve best represents the graph of the function f of x is equal to -a sine x plus b cos x, given that the constants a and b are both positive? So let's start by drawing out these curves. B cos x will look like this. Go between B and negative B. Negative A sin x looks like this. Negative A and A. So just by adding coordinates, we can eliminate two of these. So having a look at x equals 0, the y value there is equal to 0, and here the y value is equal to b. 0 plus b is b. B is a positive number, so it can't be this one and it can't be this one. They're out. Now we need to try and distinguish between b and d. We can plot other points, but it's not incredibly clear. But what is clear is that we have a maximum point just after the y-axis, whereas here we have it just before. So I'm going to differentiate. F dash of x is equal to negative a cos x minus b sin x, and I want to put that equal to 0. So I will end up with negative a cos x is equal to b sin x. Dividing both sides by cos x, I get negative a is equal to b tan x, and tan x will equal negative a on b. A and b are both positive, so this is a negative number. So let's go all stations to central. When is tan negative? Here and here. And this here can be represented by a negative angle. So that would be that one there. So our answer is D. Question 8. The diagram shows a semicircle. Which pair of parametric equations represents the semicircle shown? So we start by forming the Cartesian equation. X minus 3 all squared plus y minus 2 all squared is equal to 1. And making y the subject, 1 minus x minus 3 all squared. Y minus 2 is equal to, we want the negative square root because it's the bottom semicircle. And so y is equal to 2 minus the square root of 1 minus x minus 3 all squared. Now, if we substitute in x is equal to 3 plus sine t, I get 3 plus sine t minus 3, which is sine t. Sine t all squared is sine squared t, so 1 minus sine squared t gives me cos squared t under here, and the square root is cos t. And so y would equal 2 take away cos t. Now that's going to happen in every single case. We can see here that we've got the minus that we want, but in these two cases we don't, they're pluses. And so we can eliminate A and B. Now I'm just going to plot some points, some values for t, to try and distinguish between these two. Now I'll cut to the chase. If you put in t equals 0, you get nowhere. Pi on 2, nowhere. Negative pi on 2, nowhere. But negative pi on 4 does actually help. So let's do this. Starting with C, x is equal to 3 take away sine of negative pi on 4. And I've already done these calculations. This is 3.7. Y is equal to 2 take away cos of negative pi on 4. And that's equal to 1.3. Now let's just put some numbers on this graph. This is 3, 2, 4. That is 1, and that is 2. So the point 3.7, 1.3 is probably good. Now when we check D, so that's C, here's D. X is equal to 3 take cos negative pi on 4, and that is 2.3. And Y is equal to 2 take away sine of negative pi on 4. That is equal to 2.7. Now let's have a look at that one. 2.3 and 2.7 is up here, and so D is out. Our answer is C. Question 9. Which graph represents the function y is equal to inverse sine of sine x? Okay, so remember doing this way back in year 11? Firstly, we know that inverse sine of sine is going to, they're inverse functions, so they undo one another. So we're going to end up with a graph that looks like y is equal to x. But we have that in every single case. The second important point if I just rewrite this, is the domain. That's the way to tell the difference with a couple of these. The domain here of sine x is unlimited. It's all real x, which means we're going to have a solution for the whole domain. So it's not C. Okay. Next thing we're going to do is just plot some points. So let's plot, say, pi. Pi will give us a bit of a clue what's going on. So y is equal to inverse sine of sine pi. Sine pi, of course, is 0. So inverse sine of 0, which is 0. So it could be A, it could be B, it is not D. Now, what else can we do? What's the difference between A and B? Let's test this point here. This is 3 pi on 2. So y is equal to inverse sine 3 pi on 2. Sine 3 pi on 2, let's just draw normal sine. That's -1. So inverse sine of -1. Now we need to draw the inverse sine graph. -1 is negative pi on 2. And so, it's this guy, it's A. And question 10. The members of a club voted for a new president. There were 15 candidates for the position of president and 3,543 members voted. Each member voted for one candidate only. One candidate received more votes than anyone else and so became the new president. What is the smallest number of votes the new president could have received? Right, so this is a pigeonhole principle question. We know that at least one of the candidates received at least 3,543 divided by 15, which is, what is that? 3,543 divided by 15, 236.2. So at least 237 votes. So that one's out. Now a lot of people would have just chosen B without really considering that this is question 10. So it should be a little bit more harder than that. And the clue lies with this remainder. If I do 0.2 times 15, this is the same as 236 remainder 3. So here's our candidates. I won't draw them all out. Suppose everybody got 236 votes. There are 3 votes remaining. If we distribute them like this, then we have 3 winners. And it says here, one candidate received more votes than anyone else and so became the new president. So that's not possible. One of these has to go into, say, this pigeonhole here. So it's not 237. The smallest number of votes the new president could have received is 238.